Hi everyone, welcome back to BSc Chemistry Study Room. If you are new to this room, please subscribe for more video updates. And if you have already subscribed, please click on the notification button for more video updates. Today in this video, we are going to discuss under degenerate orbitals. Orbitals of the same energy and principal quantum number are referred to as degenerate orbitals. All orbitals having the same energy or the same principal quantum number are referred to as degenerate orbitals. So to deal with these degenerate orbitals, one must always keep Obbo principle in his mind in order to make it very easy. This is Obbo principle diagram. This Obbo principle diagram is telling us more about the energy level of any atom on the periodic table. This is 1s. This 1s tells us more about the energy level, the first energy level where n is equal to 1. For example, when drawing this energy level in form of shells, i.e., this is a shell, this is a nucleus. This shell shows where n energy level is equal to 1. And as we increase the shell, that means we are increasing the energy level of an atom. This is where n is equal to 2. As we increase the shells, that means we are always increasing the energy level of an atom. So this 1s shows where n is equal to 1, 2s shows where n is equal to 2, 3s, 3p, 3d where n is equal to 3, 4 where energy level for n is equal to 4, and 5 where the energy level n is equal to 5. So this is telling us that as n is increasing or the shell is increasing, therefore the energy level of an atom is also increasing. This is Obbo principle diagram telling us more about energy level of any atom on the periodic table. 1, 2, 3, 4, and 5, where energy level n is equal to 5. So this Obbo principle diagram makes it easy in order to understand degenerate orbitals more and more. This Obbo principle diagram formula is n, but in degenerate orbitals always n is equal to n squared. So in order to solve problems, one must always remember Obbo principle diagram. So let's solve an example under degenerate orbitals. Let's solve number 1. Number 1 says, find all the possible degenerate orbitals when the energy level of that orbitals n is equal to 1, n is equal to 2, and n is equal to 3. So now let's see the first question. The first question is when the energy level n is equal to 1. Let's take it and try to solve it. N is equal to 1. So in Obbo principle, always n is equal to 1. So, but in degenerate orbitals, n is always equal to n square. That is the formula of degenerate orbitals. So, n square is 1 square. In degenerate orbitals, 1 square. So, that means we are going to obtain 1 orbital when we come to Obbo principle. This is where energy level n is equal to 1. Then we carry all the possible orbitals on that energy level. That means it's only 1s. So then we take it down and write it in degenerate orbitals, 1s. Degenerate orbitals, 1s. And we know s has no suborbitals. So now let's look where n is equal to 2. That means n is equal to 2 in Obbo principle diagram. In degenerate orbitals, n is equal to n square. That means we are going to have 2 square. With 2 square gives us 4. That means we are going to generate 4 orbitals when we carry all the possible n, where n is equal to 2 in Obbo principle. This is the energy level where n is equal to 2. So that means we carry all the possible orbitals on Obbo principle, 2s, 2p. So we are now to generate the remaining orbitals. We know 2s in our previous video has no suborbitals. We take it down, 2s. But 2p, we know in our previous video, it has 3 suborbitals. So now we are writing it 2px, 2py, and 2pz. So when we count 2s, 2ps, 2py, 2pz, it is 4. That means we obtain our 4 orbitals from Obbo diagram. So now let's go where energy level n is equal to 3. So degenerate orbitals n is equal to n square, which is equal to 3 square. And degenerate orbitals 3 square. So and 3 square give us 9. So this is telling us we are going to generate 9 orbitals when taking all the possible energy level where n is equal to 3 in Obbo diagram. We are going to carry 3s, 3s, 3p, and 3d. So in these orbitals, we are to generate the remaining orbitals. We know 3s has no suborbital, s has no suborbital, 3s. But we know p has 3 suborbitals, that is 3px, 3py, and 3pz. Now, when it comes to d orbitals, we know d orbitals has 5 suborbitals, so we are writing them down. We have 3dxy, we have 3dyx, we have 3dzx, we have 3dz square, and the last is 3dx square minus y square. So when we count, we can see that it is 9 orbitals. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is how we can obtain or degenerate orbitals from Obbo principal diagram. So this is the end of our today's lesson. Don't forget to like, comment, and subscribe, please. And if you have any question, please drop your questions in the comment section below. Thank you very much. Thank you for watching.